This is lesson 3-7, solving absolute value inequalities. You do not have to copy this information to your paper. Just watch and follow along. Absolute value refers to the distance from zero. Recall when we solved absolute value equations. We set up and solved two equations, x equals -4 and x equals +4. X is exactly 4 units from zero. Now when we think about absolute value inequalities, we got to consider the inequality symbol. Here we have the absolute value of x is less than 4. Then that means x is less than 4 units from 0. Therefore, it will be open circles because it's not included in equals to, open circle, and it's shaded less than 4 units from 0. Notice x is greater than -4 and x is less than 4. One way to help you remember this is less than. So if we consider an absolute value of x is greater than 4, then that means it's greater than 4 units from 0. So here again, open circles, but greater than 4 units from 0, it shades x is less than -4 or x is greater than 4. To help you remember, you can think about great or. So as you recall with compound inequalities, the set notation and number lines will follow for a less than an and compound inequality, and a great or will follow an or compound inequality. Pause the video at this time to copy this information. Example number 1. We have the absolute value of x plus 5 is less than 2. Notice the symbol is a less than symbol. So when we work out and solve the inequality, our set notation and graph should be an and. X plus 5 is less than 2 units away from 0 on the number line. So this means we're going to set up and write x plus 5 is greater than -2 and x plus 5 is less than 2. If it's less than 2 units away from 0, it's got to be greater than -2 and less than +2. The less than symbol tells us our set notation and graph when we get there. So set up and write your two inequalities. The first inequality is no absolute value bars. Reverse the symbol and make your 2 negative. That will be the most important step to remember, reversing the symbol and making your number negative. The second inequality is exactly as the problem's written with no absolute value bars. Solve each of the inequalities. We'll do so by subtracting 5. We find that x is greater than -7 and x is less than -3. Because this will fit an and compound inequality, we'll set up our set notation. Our set notation will be the set of all x's. Remember, our values go in from least to greatest, so -7 is less than x is less than -3. Notice it follows the format of an and compound inequality. And also, if you look at your inequality for the x is greater than -7, when we put it in our set notation, the inequality is still pointing to the -7. Now graph the solution on a number line. It should shade to the inside as an and compound inequality always does. An open circle on -7, an open circle on -3, and it does shade to the inside. Always check to make sure that it really shades as you expect it to be. We will check a number from the shaded region always in the original problem. The original problem was the absolute value of x plus 5 is less than 2. You will not need to check in the 2 inequalities that you use to solve. Just check in the original problem. So the absolute value of -5 plus 5 simplifies to be 0, which is less than 2. Example number 2. We have the absolute value of 3x is greater than 9. That is a greater than symbol, so this should set up and solve like an OR problem. Great OR. Think about it. This means that 3x is greater than 9 units away from 0 on the number line. So we're going to set up our two inequalities. 3x is less than negative 9, or 3x is greater than positive 9. It's got to be greater than 9 units away from 0. So that would be less than negative 9 or greater than positive 9. So those are our inequalities that we'll use to solve. The first one, you flip the direction of the inequality symbol and make your number negative. This is an OR problem because of our symbol, great OR. The second inequality is just as it is with no absolute value bars. Now solve each of the inequalities. Do so by dividing by 3. X is less than negative 3, or x is greater than positive 3. This should graph and be written in set notation like an OR compound inequality. The set of all x's such that we're going to put the smaller value first. So x is less than negative 3, or x is greater than positive 3. You will use the word OR in the set notation. Now make your number line. We will have an open circle on both the negative 3 and the positive 3. Notice for these graphs, the open and closed circle will always be the same because it comes from the original problem. If the original problem is with or without the equals to, you will do so in the next steps, making it with or without the equals to. So an open circle on negative 3 and it shades to the less than side. An open circle on positive 3 and it shades to the less than side. So it does shade as we expect it to the outside, like an OR problem would be. Because we have two areas on the number line that are shaded, you'll need 2 checks. Again, always remember to check in the original problem. So negative 4 is one of the values we will check. 3 times negative 4 gives us negative 12. When you take the absolute value, that gives us a positive 12 is greater than 9, which is true. Then we will check a number from the other shaded region. Always use the original problem to check. So 3 times positive 4 is 12. When you take the absolute value of a positive 12, it's 12. And that is still greater than 9, so it does check out. Always check from a number in the shaded region. We have 2 shaded regions, so you'll need 2 checks. Example number 3. We have the absolute value of x plus 1 is less than or equal to 5. Remember, just like when we were solving absolute value equations, you'll need to isolate the absolute value bars first. This means subtracting 1 on both sides. So we have the absolute value of x is less than or equal to 4. Think about it. This means that x is less than or equal to 4 units away from 0 on the number line. Less than or equal to 4 units. This means that x is going to have to be greater than or equal to negative 4, and x has got to be less than or equal to positive 4. And these are the 2 inequalities that we will use to solve. This is a less than because of the symbol. This is being an and compound inequality. X is greater than or equal to negative 4. We reverse the direction of the inequality symbol and make our number negative. That's the most important step to remember. And x is less than or equal to 4. The second inequality, you just drop the absolute value bars. We will not need to solve any further. X is already by itself, so we're ready to write it in our set notation. So it's the set of all x's such that -4 is less than or equal to x, less than or equal to +4. Put your numbers in least to greatest order. Notice with our smaller number, -4, the arrow is pointing towards the -4, and that is still true when we put it in our set notation. And this does follow the and set notation format. Graph it on a number line. Notice I did choose to skip count by 2's. Feel free to always do so when you find necessary. I have a closed circle on -4 and it's shaded towards the greater than side. Also a closed circle on +4 and it's shaded towards the less than side. This will shade as we expected to do so, like an and problem should shade to the inside. Check a number from the shaded region in the original problem. I'm going to use -2 to check. The absolute value of -2 is +2. When I add 1, that gives me 3, which is less than or equal to 5. Remember, always check in the original problem. Example number 4. We have 3 plus 7 times the absolute value of x is greater than or equal to 38. Some students may think that you add 3 and 7 together first. That would be incorrect. You have to undo the operations. Isolate the absolute value by first subtracting 3 and then divide by 7. We now have the absolute value of x is greater than or equal to 5. Now that our absolute value bars are by themselves, we're ready to make our two inequalities to solve. Think about it. This means that x is greater than or equal to 5 units away from 0. So this would mean x has to be less than or equal to -5, or x is greater than or equal to +5. If it's greater than or equal to 5 units away from 0, we'll have less than or equal to -5 or greater than or equal to +5. This is a greater than symbol, so it would be a great or problem. X is less than or equal to -5, or x is greater than or equal to +5. Put your numbers in set notation. It's the set of all x's such that for an or compound inequality, you just set them right into the set notation with the word or in between. So we have that x is less than or equal to -5, or x is greater than or equal to +5. Now graph it on a number line. Notice we'll have closed circles on both -5 and +5. Your circles should always be the same, either both open or both closed, because it's always going to come from the original problem. When you make your two inequalities, keep it with or without the equals to, depending on how it started. So a closed circle on -5, it shades toward the less than side, as well as a closed circle on +5 and shades towards the greater than side. This does shade as we expect it to do so, like an or problem. Always check a number from the shaded region. We have 2 shaded regions, so we should have 2 checks. We're going to check in the original problem. So first, checking with -6, the absolute value of that is a +6. Now multiply 7 times 6 and then add 3. We find that 45 is greater than or equal to 38. We'll also need to check a number from the other shaded area. 7 times positive 6, once you take the absolute value, and then add 3. Again, this does check out. Example number 5. We have 4 times the absolute value of x plus 2 is greater than or equal to 12. Be very careful that the 4 will not distribute to the x and the 2. The distributive property does not work with absolute value bars like it does with parentheses. You will need to isolate the absolute value bars by dividing by 4. So we get the absolute value of x plus 2 is greater than or equal to 3. Pause the video at this time to set up and solve the remainder of this problem. Let's check your answers. It is a great OR problem because of the greater than symbol. So the first inequality you should have written as x plus 2 is less than or equal to negative 3. Reverse the direction of the symbol and make the 3 negative. Or x plus 2 is greater than or equal to positive 3. Check your solutions when you solved. You should have subtracted 2 to find that x was less than or equal to negative 5, or x is greater than or equal to positive 1. Your set notation will be the set of all x's such that x is less than or equal to negative 5, or x is greater than or equal to positive 1. Let's now check your number line. We should have had closed circles on both the negative 5 and the positive 1, and it should have shaded to the outside. An OR compound inequality will always shade to the outside, the same as a great OR inequality with absolute value bars. It shades to the outside. Now let's do our check. Always check in the original problem. We have 2 areas that are shaded, so we'll need 2 checks. When you check, you're just working it out using order of operations. Notice both solutions check when we use negative 6 and positive 2. Example number 6. Follow the steps on the screen to work this problem on your own. Pause the video at this time. Let's check your solution. You should have first subtracted 9 and then divided by 5 to isolate the absolute value bars. Once you isolate the absolute value bars, you'll make 2 inequalities. The first one, check your work. You should have reversed the direction of the inequality symbol and then made the 4 negative. This is a less than problem, so it'll say and. The second inequality, we just have no absolute value bars. Just copy the problem as it is. X minus 3 is less than 4. Check your solutions when you solve. We should have added 3 to both sides. So we get x is greater than negative 1 and x is less than 7. For your set notation of an and, you will not see the word and. You put your numbers in least to greatest and just smush them all together. Negative 1 is less than x is less than 7. On our number line, they will have open circles and shaded to the inside as an and compound inequality should. Check and correct your work if needed. Now for our check, we're going to check a number from the shaded region in the original problem. Notice that 14 is less than 29, so it does check out. Example number 7. We will do this problem together in class. This concludes Lesson 3-7, Solving Absolute Value Inequalities.